extended access list configuration. We're going to be talking about when we will use extended access lists, number ranges that define the extended access lists, the commands to configure it as well as go in and configure some extended access lists, named access lists, which we can configure in standard or extended formats, as well as troubleshooting our access lists. Let's take a look at a slide here, and we'll talk about when to use the extended access list. Again, extended is a number 100 to 199, or 2000 to 2699. And again, those numbers tell the router two things. One, it tells it that it's the IP protocol, and two, it tells it standard or extended. In this case, it is extended if we're using that number range right there, 100 to 199 or 2000 to 2699. We use an extended access list when we want to block particular types of traffic, like web traffic, or a specific traffic from a specific source address going to a specific destination address. So we use an extended access list when we need more granularity in the type of traffic we're blocking or filtering. I can also block or filter ranges of port numbers. When we look at the access list outline, it's access list and then the number. And again, it's got to be a number within these ranges here to be extended. Permit, and then the protocol. I could specify the layer 3 protocol like IP, which would block everything associated with IP or permit everything associated with IP. Or I could specify a different layer 4 protocol, TCP, UDP, or parts of the IP protocol suite like ICMP, Internet Control Message Protocol, which ping is a great example of that, ping and traceroute. I can block pings using access lists, extended. Filtering based on the source address and the port. And again, with the port number associated with the source address, I can go ports greater than 1023, so ports greater than the common ports, or ports less than 1024, which would be the common ports. Or if I use the EQ, I could specify a particular port, like port 80. And what's great about this, I can do this for source and destination address and port number. So these are our options. I don't have to specify a port number though. I can do source and destination address and block all traffic from a source to a destination. So I don't have to specify the port number. But specifying the port number again gives me a finer control of what type of traffic I'm filtering out. I want to take a look at a diagram and we will run through some sample extended access lists. I want to look at a scenario in this diagram where this server is an FTP server. So this is the server and it's running the FTP service. So if we're looking at the OSI model, 7-layer model, FTP is running on that system. I want to allow access to this machine only to the FTP service. So this is the only guy with FTP access on the server. Be able to download, upload files, whatever. All the other machines, well, this one's in the same subnet. All the other machines and all the other subnets should still be able to ping this machine and function normally. Maybe there's a web server on here as well. Whatever. I want them to be able to access this server for any service, but only this machine is going to be able to access the FTP service. So what we're going to do is we're going to open up Notepad and take a look at the access list we would create to allow that to happen. I've labeled the interfaces. You can see Ethernet 0, Serial 0 on each of the routers, and I've brought up Notepad so we can see the access list we're going to be typing out. Again, .13 is going to have access to the FTP service over here. Only. All the other machines will still be able to access the server for any other service, just not FTP. So, what we're going to do is we are going to set up an access list. And this is an extended access list to be able to specify particular traffic. So we'll go access list 101. We're permitting the traffic. Now, we need to know something. We need to know the layer 4 protocol that FTP works with. You might know it off the top of your head, you might not. We need to know whether or not it works with TCP or UDP at layer 4, because we're going to be telling the router to check TCP or UDP packets. So we have to know the layer 4 protocol. If you don't know right off the top of your head, it's easy to look up. You can Google it, whatever. There's also a file on our computer called the services file, and it'll allow us to view those protocols and port numbers that our computer uses. So let me pull up that file. I've brought up the file here, and you can see the path to it. It's available on all your Windows boxes. C, Windows, or the system root, System32, drivers, etc folder. We will see the services file. And I can just open that up with Notepad, and I can go in and take a look, and it shows me all the main services and standard ports that my system uses. We're looking for FTP. Now FTP uses 2 ports, the data and the control information. The control information is used to set up the connection and share the information. The data actually gets transferred on port 20. Typically, blocking port 21 or allowing port 21 and letting everything else go would suffice. So we're going to block or only allow a computer with an IP of 13 to be able to access that server at port 21. And we're going to tell it to look at TCP packets, not UDP packets, so we know that FTP works with TCP at layer 4. If we get it wrong, it won't filter the traffic appropriately. Let's go back to Notepad and finish typing out that access list. I'm back at Notepad, and now we know what to type here. TCP, the protocol that we're typing is TCP. So access list 101, permit, TCP, and now the source. This machine down here, 172.16.0.13 is the IP address. And now we have to specify the wildcard mask. Do we just want this one IP? If so, I'm just going to use host instead of the all 0 wildcard mask. So this is my source address. So coming from source 172.16.0.3, now a common misconception would be when this machine sends information out to that FTP server, and it's sending the packet information, that the source port is going to the FTP server. The destination port is 21 to set up the control information and set up the link. The source port is not 21. The source port would be like a common port above 1020 or a registered port above 1023. It's not going to be using port 21. Port 21 is not for the client FTP access. It's for the server. When you're running the FTP service, you're running at port 21. The client's using a different port. So we don't specify the source port for the client. We're just worried about the destination of being 21. So let's go back to our Notepad and take a look at that. So we're going to specify, we're just going to leave any port. So any port coming from 172.16.0.13 going to, let's take a look at that subnet right there. It's in the 10 subnet, 10.0.0.44. And that's a host as well. To mix it up, we'll use the wildcard mask of 0000. EQ, because we're just worried about port 21. EQ 21. So what that has done, it's allowing traffic from this machine to go to this server at port 21. Now, all other FTP traffic going to that server, we want to block. So now we're going to block it because we are allowing any additional traffic aside from the FTP traffic. So we're denying TCP traffic from any source going to, and we'll use the host again, host 10.0.0.44. I cannot type right now. EQ 21. So we're denying TCP from any source to the destination. So it's going to check all TCP traffic from any source going to destination host 10.0.0.44 at port 21. The reason we have to have that in there is because we don't want to block web traffic or whatever this server might be running aside from FTP. The only thing we're worried about filtering out to where this is the only machine that can get to it is the FTP traffic. So at port 21. Now the order is very important. If I put this deny statement first, what would happen is even when this machine went to go through and check it against the statement and go, oh, that's part of any, so I'm going to deny you. But since the permit statement is first, this machine will go ahead and go through, the computer will check, the router will check and go, oh, that's you? It says to permit you. Okay, you can go through. Another machine, let's say this machine right here with an IP of 192.168.1.95, if it tries to go, it won't match this statement because it doesn't have the same source address. So it'll go to the next statement. And it'll go, oh, you're a part of any, you're denied. So remember, with an access list, as soon as it hits an entry in the access list that it matches, it'll go ahead and carry that out. It won't go to the next line. So when this machine goes through, matches the statement, goes ahead and permits it. It doesn't bother checking the next line. And that's very helpful, especially in a situation like this, when we want to block all other systems using FTP traffic. Now, the last one. We do want to allow all other traffic, like web traffic, TFTP, DNS, whatever this server might be running. We will want to allow all other traffic. So we're permitting. Now, very important with an access list here is the permit statement. There are multiple different types of protocols associated with IP. Pings, all the TCP, all the UDP traffic. There's all kinds of stuff associated with IP. If it's an IP access list and we're permitting all IP traffic, that means we're not going to be blocking anything. So our permit statement, if it were to just say permit TCP, what would happen is any traffic using UDP or pings or anything like that would get blocked. Our permit statement, if we're permitting all the traffic, has to be IP. If we're just allowing TCP traffic, that means all the other type of IP traffic isn't going to be able to go through. So very important that you put IP, not anything else. Any. So permit IP, any source, any destination. Since there's no specification with the port numbers, it's at any port number. So this access list we can go in and set up on the router. So all I have to do is highlight it, copy, and then we'll go into our router and apply it. So I'm in my router. I'm going to go into global mode, and I'm going to paste that access list into global mode. And it left off my other any. So that last statement, for some reason, I didn't highlight my other any and paste it in there. So I'll have to type out those three characters again. So anyway, our access list was pasted in there. Let me check that out. Oh, I forgot the second any. Any source, any destination. So I pasted my access list in there. Now if I do a show run, I can check it out. And I can view my access list. Here it is, access list 101, permit that one host to the FTP server at 10.44, denying all other traffic to 10.0044 at FTP, and allowing all other traffic. So anything else going to 10.0044 will be allowed from any other system. But I haven't applied it to an interface. So let's check where we would apply it. Now, you think I might apply it here on the way in, but that wouldn't affect these guys over here. We're worried about protecting this server. And it's extended, so we want it as close to the source of the traffic as possible. So to be able to filter traffic from everybody going to this server, obviously aside from this guy, we're not worried about filtering him out. So filtering the 192.168 network and the 172.16 network as close as we can get to those is serial 0 on, let's say this is Palestra B, and this is Palestra A, Palestra B, and Palestra C. So on router B here, to be able to filter that out, we've got to go to serial 0 interface and apply it in which direction. Now you have to remember, this is before the routing decision on this router. It's entering the router. If we look at this as a door, it would be on the way in. So we've got to go to serial 0 and apply it on the way in. So our command, now we specify IP. Remember, when we create the access list, we don't specify IP because the 101 says IP and it also says extended. IP access group 101, refer to the access list, specify on the way in. Do a show run. And I can go in and take a look at the access list. I can see that it's applied to serial 0 on the way in, and I can view my access list. Very important to check that out. Now, I can also do the show access lists, and I can see my access list that way. There's also another show command, show IP interface serial 0. And what that'll do is, this is the only show command aside from show run that I can see whether an access list is set on my interface. I particularly like show run better, but I can check it out right here. Inbound access list is 101. So right here on serial 0, I can see that there is an inbound access list of 101 applied to the interface. So this is another show command besides show run that you can use to view the access list on the interface. If I like it, I'll go ahead and save my configuration. Let's go back to our diagram. I'm going to clean it up and we'll take a look at an additional scenario. Alright, I brought up the diagram. I'm just going to go over another scenario here. And I've added another Ethernet interface to router A, Ethernet 1. So we've got router A, router B, and router C. And we're just going to say that this subnet coming off of Ethernet 0 is the 1.0 subnet, coming off of Ethernet 1 is the 2.0 subnet. I want traffic to be able to go between the subnets normally. So these computers over here can talk to these computers over here in the 2.0 subnet. Let's say their IPs are also 12 and 13. So we've got 172.16.1.12 and 1.13, and 172.16.2.12 and 2.13. However, these machines right here, I want these machines to be able to go to the outside world, but only to this public IP address. Since we're running private IPs in the background, let's just say this router is running NAT. Let's say they all are. I don't want to get too involved in the IPs right now, but I want to allow access to this public IP from these machines, but these machines cannot go out. So these machines can talk here, but they can't get out, and this machine can get out, but they can only go to this public IP. So let's take a look at the access list that would accomplish that. Access list, it's extended, so I can use a number greater than 100, lower than 199, or 199 and below. I am permitting traffic, and what I'm going to do is we're going to apply the access list on serial 0 on this machine, on this router, on the way out after the routing decision. That way it won't affect these machines right here being able to communicate. So they can still have communication back and forth between the subnets. However, these guys are going to be sad because they don't get to go out of serial 0. Only these guys down here in the 2.0 subnet get to go out serial 0. So let's go back and finish that access list up. And I'm permitting, and I'm just going to permit all traffic, so IP traffic from the source now. So the source is going to be 172.16.2.0. That's this subnet down here. And what I did is I used a wildcard mask, 000.255, What that does is it says, okay, the first 3 octets have to be 172, 16, and 2. Last octet doesn't matter. These guys won't be able to go because their first 3 octets are 172, 16, 1. So that won't match them. So they're not permitted. 2, destination, host. Whatever services are running back on here, they're all going to be represented by that one public host IP of 20.9.77.3. And I'm going to allow any port, so I don't have to specify the port. At this point, if I don't want any other traffic going out of this interface, if that's all I want is this subnet to be able to go out to these machines over here, I'm done. I have my one permit statement. Permit, everything else is blocked because of the implicit deny any at the end of every access list. It's there, so I don't have to say it. So I'm allowing this subnet 20 to go out to this one public IP, and that's it. So I don't have to specify any deny statements. One permit statement works just fine. Whoops. Now all I have to do is go to the router and apply it. Alright, I'm back at my router, and this one's going to go on the serial 0 interface on the way out. So I'm going to go into privilege mode here, global mode, paste the access list. Now I have to go to the serial 0 interface and apply it on the way out using the IP access group command. If I can type it, 111 out. Do a show run. I can verify that the access list has been applied to the interface. The old one is still there, so I will get rid of that. And again, to get rid of something, all I have to do is type in what I see in the prompt here. Interface serial 0, so interface serial 0, enter, no, and if I want to, I can get rid of the old one just by copying and pasting right into the prompt. It makes it real easy. Do a show run. And much better. I see my access list 111 is permitting traffic from the subnet 172.16.20 to host 20.977.3 on the way out of serial 0. And back to our slide there, we can see here serial 0 is right here. It's going out of serial 0 and allowing it to go to this destination IP. Now what I want to do is I want to go in and take a look at how we would create similar access lists but using named access lists. Instead of relying on the number like access list 101 or 111, instead of relying on that number, we're going to be using names. And the nice thing about names is it's a little bit more intuitive, and you can actually remove individual statements without deleting the entire access list. Let's go back to the prompt and take a look at what I mean. Alright, I've brought up the router prompt, and now we're going to go in and configure a named access list. So we get into global mode, and the big difference with the named access list is we start by telling it the protocol. Remember, with standard or extended, the number tells it the protocol, and then standard or extended. But here, we're telling it it's going to be an IP access list. So we say, hey, this is an IP access list, and now it wants the type of access list. It could be a logging access list, but we're after standard or extended is what we're looking at. So it wants the type of access list. So let's say this is going to be an extended access list. And now it wants a name. We can give it a number if we would like. But this is the big plus here, is we can give it a name. So we could call it block ping. So we're going to give this thing a name called extended access list block ping, and it can be intuitive, meaning that we're going to be blocking pings with this access list. Notice it takes us to a new mode. Configure extended named access list mode. All we do now is we start with the permit or the deny. Permit or the deny. Tripping over my own tongue there. So we don't have to say, hey, this is IP access list extended block ping. Now we just enter the components of it. So we're saying deny ICMP, just like we would finish up any other access list. We're blocking pings now. Any echo is the echo request for a ping. And now our permit statement, permit IP any. So we go in and we create it and we're done. If we do a show run, we can go in and take a look at it. IP access list extended block ping. So here's our named access list and here's the components of it. Now maybe I didn't want to block the echo request, but I wanted to block the echo reply, which is the response to an echo request with ping. So the nice thing about named access list, but it doesn't turn out to be that big of a benefit. I'm just going to copy this so I can get into that access list mode. Copy. Paste to host. There it is. I want to remove this one line. So instead of typing it out again, I'm just going to copy, type no, paste to host, enter, Control Z, show run, and verify that that one line is gone. So I can remove an individual statement out of a named access list. I can't do that with a standard or extended access list because it'll remove the whole thing. Again, this is an extended access list, but it's a named access list. If I did it with a non-named access list or a regular access list, I'd remove the whole access list. I can't remove one statement. So what I'm going to do is I'm going to put that statement back, but I'm going to specify echo reply instead of echo request. So I'll paste that there, get in my access list configuration mode, and I'm going to deny ICMP any echo reply. I think it's dash reply. Let me check it out. Yeah, dash reply. Enter. Control Z. Show run. So I can remove an individual statement and put another statement back in. But the big problem is I can't reorder the statements. So my permit statement is now first. With the permit statement being first, permit IP any, all traffic will hit this first statement and go ahead and go through. Traffic will never reach to this next statement in the access list, so I will never be blocking echo replies. So the main benefit to this really, I think, is the ability to just give it a name. But again, by creating a notepad, you could save the access list in notepad with a particular name and have all the information there. This is just another way to create the access list on the router that's a little bit more flexible. Alright, let's talk about what we're going to do when we want to troubleshoot our access lists. And we're going to go to a slide here because I want to make some points first before we come in and use our show commands on the router. I brought up this slide because there's some points I want to make with troubleshooting, especially with an extended access list. The fact that it's extended and you're blocking port numbers and not all traffic from certain sources or destinations, very important. And it makes it much more complicated. It's important to know your traffic. If you're filtering traffic going to or coming from a particular subnet and you've got a bunch of different services on there that you want outside devices to be able to access different services on different machines, it's very important to understand the port numbers that these machines are listening on and what services they're offering, who's going to be accessing the service, all that information. Very important to get that information and know it well. If you don't know it or you get the wrong protocol or port number, you're going to be blocking unnecessary traffic or allowing unnecessary traffic, which may be worse. Make sure your permit statement is correct. If you don't have at least one permit statement in your access list, it's not going to allow the right traffic. So your permit statement, very important to make sure it is correct. Make sure you're permitting what you want to permit. Verify all your IPs in the access list. Look very closely. Read them out loud to yourself. Remove the access list and see if the traffic can pass. If you're having trouble getting particular traffic in, remove the access list and see if that traffic can go in once the access list is gone. If that does it, then you need to look closely at the access list. If you're still having trouble figuring it out, try entering the access list one line at a time. Just do it one at a time, test the traffic, and then go to the next line. That way you'll be able to isolate the line in the access list that's really causing your problems. Let's go back to the router prompt, use a couple of show commands, move around in there to verify our access list creation and make sure we can see where it's applied, all that. Just a couple basic show commands. I'm at my router prompt and we're just going to take a look at the router, the access list on it, using the basic show commands. First one, show running config. Probably my favorite command out of all of them. Ethernet 0, I can see there is an access list applied. Access list 101 on the way in to Ethernet 0. Serial 0, I can see there is an access list of 102 applied on the way in. This access list is not applied anywhere, so I should just get rid of that. And if I want to get rid of that and clean up my router, all I have to do is copy, go into global mode, type no, paste, gets rid of it. Now I want to do a show run to actually view the access lists that are applied to the interfaces. That access list will be gone. I always get rid of any excess stuff because I don't want to worry about it confusing me when I'm looking at my router config. So I've got some ports here. I'm permitting a bunch of ports. I'm blocking all other ports. I'm stopping this host 172.16.5.3 from getting out to any destination with FTP for whatever reason. I'm permitting all other FTP traffic and the data. And it's important if I'm just running permit statements like this and not just denying traffic that I do permit the data as well, because whatever's not specified here when I'm just running permit statements will be blocked because that implicit deny all at the end of every access list. So I'm just permitting FTP traffic, data, TFTP, web, and port 443. That's on my Ethernet interface. So that's coming from any source going to those different services I'm allowing out on the web. This is my serial one on the way in, access list 102, deny. I'm blocking pings. Any echo, that's a very common access list to block pings at your serial interface. I don't want people to be able to ping me and find out that I'm there. And I'm permitting all other traffic on the way in. If I didn't have this permit statement, it'd block everything. Show IP interface. Again, will allow me to see that an access list is applied to an interface inbound. Inbound access list 102 on serial, no outbound access list. So very important to know the directions. Make sure you have the direction correct. And here's where you can check it out, as well as the show run. If there is a problem with the access list and I figure something out and I don't have it in Notepad, I'll copy the access list, open up Notepad, and paste the access list in Notepad and make my changes. So maybe I might want to make a change. Maybe, I don't know, instead of TFTP, I'm going to allow a different service or something like that. So all I'd have to do is go in here and make my changes, highlight it, copy it, put it back into the router. But first, I would just remove this access list by going no access list 101. If you check this out, as I was pointing out earlier, I can't remove an individual statement from a standard from a regular access list, extended or standard. If it's named, I can remove an individual statement. But here, all I did was no access list 101, and I specified this information just like it's here. But watch when I do a show run. The whole access list is gone. Taking a look at it, the whole thing's gone. That's why it's nice to work in Notepad, because if I want to remove a particular line out of Notepad, I just delete that line, Control A, Control C, remove it from the router, and paste it back in. Now the whole thing's back, and I don't have to worry about typing all that stuff over. If I do a show run, I can see that my access list is back. So it makes it pretty easy to go in and do that. Again, the key thing is there's not a lot of tools here with the access list other than using your show run and really verifying what the access list is doing and making sure it maps to what you want to accomplish with your network. So we have talked about when we use our extended access lists, the number ranges for them, the commands we use to create them, as well as going in and creating a few different access lists. Named access lists, again, I don't see a huge benefit other than the name. It's a little nice to have the name, and you can remove an entry, but you can't reorder them. So typically you'll still be configuring them in Notepad. And troubleshooting, very important to pay attention to the little details while you're doing your troubleshooting. And know your traffic. Know your traffic. Know what traffic you want to allow and what traffic you want to deny. Very important.